This is the second video over Chapter 39, Taylor and Maclaurin series. In this video we will do example 239. Example 239, we are asked to find the Maclaurin series for f of x equal to sine of x and determine its radius of convergence and its interval of convergence. So to start with, we take some derivatives. So sine is infinitely differentiable, so we can take derivatives of any order. So we start by taking the first, second, third, fourth derivatives, etc. And with sine, we see that after a while, we start to repeat. The first derivative is cosine, the second derivative is sine, third derivative is negative cosine, fourth derivative, we're back to sine. So we evaluate these derivatives at 0, f of 0, the first derivative evaluated at 0, the second derivative of f at 0, third derivative, fourth derivative, etc. So we evaluate these until we see a pattern. So we see that the Maclaurin series for sine, we start with x, and then we have a 0, and now here we have the third derivative at 0, so we have negative 1, that's our third derivative evaluated at 0, divided by 3 factorial. The fourth term is 0. For the fifth term, we're back to the first term again, so we have our derivative evaluated at 0 is 1, divided by 5 factorial, and we see that this is our Maclaurin series. So then we write it out in terms of a formula. We have, it's an alternating series. When n is 0, our coefficient is positive. So we have n equals 0 to infinity, negative 1 to the n. What is the exponent for each x? It's 2n plus 1. And we're dividing by 2n plus 1 factorial. So this term right here is the Maclaurin series. And now we want to find the radius of convergence and the interval of convergence of this series. So for that, we perform the ratio test. So we take the limit as n goes to infinity of the nth plus 1 term of the sequence divided by the nth term, or in this case multiplied by the reciprocal of the nth term. So we have the n plus 1 term. Notice that for the n plus 1 term, we have 2 times n plus 1 plus 1. So that's where the 2n plus 3 comes from. The same thing here. So this is the n plus 1 term. This is the nth term. This is the n plus 1 term, the nth term. Factorials and exponents simplify nicely. So what this simplifies to is x squared divided by 2n plus 3 times 2n plus 2. As n goes to infinity, this limit is 0 for all x. Since this limit is 0 for all x, that tells us that the radius of convergence is the entire real line. And if the radius of convergence is the entire real line, then the interval of convergence is infinity.